Welcome to Black Hat Briefings, held November 21st through the 22nd, 2001 in Amsterdam. This is videotape number 1, Protecting Your IP Network Infrastructure.
IP network security. So I'm Sebastian Lacoste-Seris, working for Col Telecom in Switzerland. Nicolas Fischbach is also working for the same company. We will present you, so it's a continuation on FX talk about network security. So we'll come back shortly on the layer 2 and routing protocol security issue. And we will go on other fields like DDoS and worm protection, SNMP remote administration. And we will have a small talk about integrated checking and what you can do with MPLS and IPv6. Okay, so I like to apologize because we made some small changes with the slides you have in your folder. So the presentation will be available on our website anyway. So I will go shortly on the first part. So the attacks you can have on Ethernet network. So as FX said, you have a large panel of attacks you can have on RP with spoofing and cache poisoning. So I won't come back on this issue. You can play a lot also with protocol like HSRP and VLANs that produce a redundancy on network equipment. I will go a little bit deeper on STP and VTP attacks for trunking protocols. Okay, so as FX said, you have some issue with some equipment that accept tagged frames, so trunk frames on non-trunk ports on switches. So it's the case for Cisco equipment. So the thing you can do to protect yourself against an attacker that will be connected to your network and would like to inject tag frame in your network. So here you have an example of the configuration you can have. So basically what you have to do is activate the BPU guard feature on the Cisco switch. Qu'est-ce que ça fait? Okay, so you have two kinds of configuration depending on what kind of multi-layer switch, what configuration you are using on your multi-layer switch. So you have the hybrid mode when you are using Catalyst OS on the supervision card and iOS on the MSFC card. And you are on a different configuration if you are using Cat OS on the supervision and MSFC card. Okay. One feature that is also available and that you are strongly encouraged to activate on your router is to limit the bandwidth for broadcast traffic. So you can defeat people that will try to flood your network. So on the switch, you can define the percentage of traffic which is allowed for the broadcast traffic. Okay, as FX already covered most of that, but I will just come back on the point that VLANs have never been designed for security. So you can build some secure network with them or enable some security with VLAN, but you have many ways of defeat VLANs. So the one big point is that the switch that will implement the VLANs is a big single point of attack on your network. If anybody manage to do something on this switch, change the config or inject traffic on this switch, your whole security system will be defeated. By default on the Cisco device, all the VLANs are in the VLAN 1. So you should change that. And this should not at all be used for the native VLAN of the trunks. there is a nice feature which is a VMPS, so it's a VLAN management policy server. It allows you to assign dynamically the VLAN membership of your station depending on the MAC address. So it's not depending on which port on the switch you are connected to, it depends on your MAC address. So of course, if you can spoof the MAC address, you can choose in which VLAN you want to be in. So one way of jumping between VLAN is to inject, one way is to inject frames in the tag frames in the switch. Another one is if you have, you are in the same VLAN as a native VLAN for the trunk, you are allowed, or the Cisco device will accept from you tag frame. So you will be able to choose in which VLAN you want to inject the traffic. Another feature that we have discovered on the device is that you can do VLAN bridge. It's used for non-IP-based protocol to offer bridging between two VLANs. This means at the layer 2, the switch will allow the traffic to jump from one VLAN to another VLAN. So a misconfiguration or a change in the configuration for VLAN bridge could allow you to bypass all the VLAN features. So, and to freely jump from one VLAN to another one. There is another a nice feature that you can that Cisco offers you, which is called private VLAN or edge port feature. This allows you to partition or to block the traffic between different ports on your equipment. So this port isolation is not based on IP, MAC address, or VLAN. It's based on the physical port you are connected to. We are, for example, using that on the switch when we have several customers on it, and we only want this customer to talk to our management station or to our firewall, and we want to forbid the customer to talk to each other. If you activate this kind of feature, you have to be careful because multicast can bypass this protection. So you have to deactivate multicast on your equipment. VTP is a VLAN trunking protocol that allows you to centrally manage VLAN configuration. So this protocol works over trunk ports. If any attacker gets access to a trunk port, then he could play with this protocol and change the VLAN topology on your network. So there are basic things you can do is put your switch in VTP transparent mode and use a password. Unfortunately, the password is not encrypted as far as I know, but it will defeat some kind of attacks. Okay, DPT is a dynamic trunking protocol. It is a protocol running between two switches that are running a trunk. By default on the Cisco equipment, all the ports are in auto mode. This means if you are connected to a switch with a standard configuration, you can just set up yourself a trunk. And once this trunk is set up, you will have access on all the VLANs on this switch. So if there is some security based on VLAN on this equipment, then you can bypass all this security. So an easy thing to do is to just, first thing to do is to turn off all the trunks on all the ports on your equipment. Okay, now let's move to layer 3 things. We will go now a little bit deeper in BGP. So BGP is a routing protocol which is used between ISPs on the internet. So if you want to drive an attack that will propagate among several ISP or disturb internet traffic, this is a protocol to attack. You can have MD5 authentication between the BGP routers, the BGP peers. Unfortunately, this is not so many used. As far as I know, on the exchange point, the ISP never use that. So this will lead to a lot of attacks that we'll describe later on. As Efik said, there is a little bit of research on the BGP field. It's not public yet. I have not seen any publication. There are some tools walking around which are doing root injections. And I think more will come soon. So what is the problem with BGP? All providers are usually exchanging traffic in exchange points. And most of the time, the exchange point is just a switch where everybody connects their router. So they are in the same subnet range, and they just set up BGP session between each router to exchange traffic and routing information. So this will be an ideal point to attack BGP. So it's recommended already to do some filtering on what you are receiving and announcing to your BGP partners. So you should filter the prefixes, the network you are announcing, and also the autonomous system you are announcing. Another kind of setup you find in the field is a multi-hop configuration. In this case, the two equipment doing BGP are not directly connected. So there is an IP network on in the middle between the two equipment. So you could have a man-in-the-middle kind of attack. This means you can capture the traffic, reroute it, either by playing with a routing protocol, as Efik described, or by just putting an equipment on the line and sniffing the network. So what you should do when to monitor what's going on with BGP, you should monitor all the IS paths you are receiving from your upstream provider. So if today I'm receiving 10 prefixes from this provider and tomorrow I have 10,000, there probably is a problem somewhere. You can also filter what you are receiving from the other provider. If someone else is announcing your IS number and your networks, there is definitely a problem. Someone has injected wrong data in the network. And you can also monitor all the change on the exchange point, so on the paths that are taken and on the IRP to defeat IRP spoofing. Okay, so what you should do is definitely use password and a different password with every single provider you are pairing with. And you can also log all the changes on the BGP side, but this, on a big provider, we have like right now more than 100,000 routes in the routing table, so it's a huge amount of data and it's hard to analyze. So here you have a basic BGP configuration. The important part is, okay, you have to set a password and you have to set up filters on the networks you are allowing the other to send to you, and on the IS path you are allowed to receive. So for example, for a customer, this customer will only be able to send the network XY, and it will only be able to advertise his IS number. Okay, now what can you do? How can you disturb BGP routing and inject some data in the BGP in the routing table? So our first idea is to inject data into BGP. So what do you need to inject data? You need first to find the BGP partners. So basically, it's a router with an IP address. So to find that, you can just sniff a network if you have access to it. If you have some router with SNMP unprotected, you can just browse the router, and in the MIB you will find all the information about BGP. On the internet, you can also find looking glasses servers. They are like web-based applications that can provide you routing information. So with those interface, you can have all the routing information you need to find a BGP pair. And another easy way to find that is on the exchange point. All the routers are in the same VLAN, so you just can try every single IP address on the VLAN. Or if you know which address range is used between the two routers, usually the routers are the first or the last one of the range. So try .1, .2, 45, and so on. So once you have found what are the BGP partners, you need to inject the update in the router. So if you have not used the MD5 authentication, the only thing you need to do is spoof the packets. So if you can send a packet to the router with the right source IP address, it will nearly be done. As BGP is using TCP, you need also to hijack the TCP session. So this can be done easily if you have access to the wire, so if you can have a man-in-the-middle kind of attack. If you are on the exchange switch, if you can do IRP spoofing and redirect all the traffic through you, it's really easy to achieve. Okay, and any other way of hijacking TCP connection will work to inject packet. So how can you protect against that? Right now, the only protection you have is MD5 authentication. Another idea would be to put IPsec between all the routers. Okay, it's fine if you have a network with a few routers, like 2, 3 routers. If you have a big provider with 1,000 routers, it becomes really, really hard to put IPsec between all the routers. There is SBGP, Secure BGP, under development by Cisco. We don't really know how it will look like yet. What we know is that it will be based on a PKI for authenticating all the equipment. The only problem we see right now is this means we will need a single PKI for all the internet actors on the market. And I don't really know how they want to achieve that. So maybe it could be a solution later on. Okay, just to come back on a few vulnerabilities that was discovered on Cisco iOS earlier this year. It was found out that the ISN was predictable, so this means the TCP sequence number was easy to predict. So here you have the time dependency on the sequence number. Cisco have released a new iOS version since that correct this problem, so we can see that the ASN is not as dependent on time anymore, but is still not satisfactory. So it may come later more attack on ISN prediction. Yeah. Okay, a quick look at OSPF. Well, as FX said, OSPF is an internal routing protocol. So it's using broadcast for advertising changes. So if you have a standard configuration, it's quite easy to attack. You just need to send packets with broadcast, and then you will add routes. You can change the routing behavior. What you have to activate is authentication with MD5. So nobody can, or if somebody injects traffic, it won't be authenticated. And if you can, you should also disable the broadcast part of OSPF. So you can turn it into unicast. So you have to disable broadcast, and manually you have to specify every single neighbor of your router which will do OSPF. So you can do this last part only if you are in a small network, definitely. A lot of some ISP are using OSPF, and if you put just a basic configuration and put all of your network for OSPF configuration, OSPF will be activated on all the interfaces. So you have to be careful on which interfaces OSPF is running off, and you have to deactivate manually the interface you don't want to run OSPF. Okay, HSRP, quickly, you cannot do any authentication with HSRP. So one idea was to use IPsec between the routers to secure the HSRP traffic. Unfortunately, in some iOS version, HSRP was processed before IPsec, so you couldn't do that. Now it seems that with the latest iOS version, you can do IPsec between your routers to exchange HSRP traffic. Unfortunately, this will only work if you have only 2 routers doing HSRP, because IPsec is point-to-point. If you have more than 2 routers, you may have problems. Okay, now Nico will come on. Will talk about the DDoS detection and protection.
Is it okay like that? Do you hear me? Or do I have to put it, Walter? It's okay? Thanks. So next topic is going to be DDoS and worms, how to detect them, what you can do when you face a DDoS or worm attack. And this is more or less from the provider view, but we'll try to see what you can do in the enterprise environment too. So basically, the old way of detecting a DDoS is looking at the logs of your firewall, Cisco logs, the CPU and the line load on the devices, or the IDSs you're on the network. The good thing you have when you run Cisco or, for example, Juniper devices, you have something that's called NetFlow that allows you to do accounting of traffic exchange between ISPs, the IP flows, the protocols, and so on. The bad thing is it's send clear text of the network, but it's only accounting data, so you don't have any passwords in it and these kind of things. You will need Cisco Express forwarding. We'll discuss that in some later slides. And just activate it on this thing on every single box you have in your network and have 1 or 2 central gatherers get this information and process it there. So what you can do in a simple way with a tool like FlowScan, the 2 graphs you see are produced by that tool, is get the trends in your network and see if everything is working fine, if things are changing in the network. So if you look at the ISP or enterprise network, usually your TCP traffic is like between 95 and 100% of the traffic you should see. You have some UDP. Most of the time it's just DNS requests. ICMP is usually really low, less than 1%, and you shouldn't see any IGMP unless you use multicast in the network. So as soon as you see trend changes, probably somebody is doing something new on the network or you're getting attacked. So the graph is from University of Madison, and you see that on that part here, they are getting a huge number of new flows. And this means something is going on. So something is attacking somebody from the inside, or they're being attacked by some other external networks. Another interesting figure is that on ISP networks, most of the packets you see are 64 bytes in size, so not 1,500 or whatsoever. So it's something that's quite interesting. So this is just a quick slide to let you know how to activate the same thing on a multi-layer switch, like a 6509 from Cisco. You just have to type in some commands. It's a bit more complicated than on the router, but it's still easy. If you don't have a Cisco or Cisco device in your network, you can use the latest snapshot of NTOP to export NetFlow data. So you can even do it with a single PC running, I don't know, FreeBSD, Linux, or another Unix system, and get this information quite easily. Another interesting tool that Cisco integrated something like a year ago in their device is what is called unicast reverse path forwarding. You will need Cisco Express forwarding, that is the latest routing and, more to say, switching and forwarding technology. DCF is the same, but on the GSR, the high-end big boxes that do it directly on the line card. You will have to use one of the latest release, and it uses 30 meg of memory. So if you already have BGP running on it or OSPF or other protocols, just check the memory you have on the device before activating Cisco Express forwarding, because you may kill your box. You have 2 features in it. One is called the streak check. That check will verify that when the packets come in to an interface, it will see if the source IP address of that packet can be reached again by that interface. It's just doing anti-spoofing, but without ACLs and way faster. So that's really interesting. People were thinking, or people still think that you cannot use it when you are in an asymmetric network, like you have two different uplinks and so on. So this is not just a unicast RPF specific, but you have to make sure that the information that gets pushed to your forwarding table and adjacent table is okay. So maybe you have to play with the BGP weight, or as you will see in that slide, just use the loose check. That check doesn't check if the packet has to go out the same interface. You just see if there is an entry in the routing table for that IP address. So that means check everything, but not the default. So as long as you route that prefix in your network, it will be allowed through your router. Another thing you should do for doing DDoS prevention, I didn't say it in the start, but when you are facing a DDoS and you didn't do anything to prepare against it, you are basically dead because you cannot connect to the device anymore. You're reacting fast and do like misconfigurations quite quickly, and you lose your whole network. So if you want to prepare for a DDoS, do it in advance, be proactive. Do it really before you have to face it. Another interesting thing is just rate limit some of the protocols that don't need the full bandwidth. Like, for example, why should you see 2 meg of ICMP go over your network when you have a 10 meg line? So usually what you can do is rate limit ICMP to 8K or 64 kilobits on a network. It's way enough. You can do the same for UDP if you don't have a streaming company hosted in your hosting center and so on. You can also limit or rate limit the number of TCP SYN packets you let in or messages you let in to. It's a kind of basic SYN flood protection, but it's working quite well. To protect against this TCP SYN problems, you can also activate what is called by Cisco TCP intercept. You also have that on most of the firewalls, like Checkpoint Firewall 1. In my opinion, this can do as much good as bad. The job of a box like a router is to route and to forward packets, not to do firewall features or whatsoever fancy things they could do. So keep in mind that if you activate TCP intercept, you don't use CUF anymore. It will switch for some parts to process switching, and that is quite slow. So it doesn't work if you already have 200 meg of bandwidth flowing over the router. You can DOS yourself because what TCP intercept does, it just constructs a kind of state table and answers instead of the host that is being reached as the original destination. So if you don't send the RST from the host, if the port is not open, or if you route to null zero for blacklog routes, you will see that you're going to full that state table quite quickly, and in fact you're going to DOS yourself. So keep that in mind. So some examples, how to do it. I really don't recommend it. So it's just more or less for your information. Going deeper into ICMP filtering stuff, it's always a source of dispute. What kind of ICMP messages should you let in, out of your network? So this is basically what most of the ISPs let through on some parts. You may let the host unreachables, port unreachables through to parameter problems. So this is just an example how to basically do an access list with ICMP. One interesting keyword is the deny ICMP fragments. Why should you see ICMP fragments in your network? It's not normal traffic. Another interesting technique when you are under DDoS attack is what is called the BGP null zero trick. What you can do, basically, I have a nice scheme on the next slides. On the next slides, you can see it, and it's going to be much more easier to understand. It's pick an IP address like RFC 1918 or what is called testnet, which is also a reserved block at ARIN. Had a static route to null zero to all your devices in the network, and have somewhere in your NOC or on a secure network a router talking BGP to all the BGP routers in your network. Can be your route reflectors or every single router. And there you change the next hop for the source network that's currently attacking you, and you say the next hop for that source IP address is going to be the IP address you picked up from testnet. What will happen there is as soon as the packet hits the router, even on the line card on the GSRs, it's going to be routed to null zero. Null zero on a Cisco device is like dev null on a Unix system. So it's fast, it's non-CPU affecting, or it's really low. So this is an easy way to block the DDoS on the edge of your network and don't let it into your core. Pay attention to the fact that you are doing it with BGP, so don't redistribute that to your upstream providers or peers and so on. Otherwise, you're going to mess up the whole network by doing that. So that's the example. So it's a mix of logical and physical views. So in fact, what you have the routers where it's like the core network or where your customers are connected. You have route reflectors to avoid fully meshed BGP. And here you have this nice master BGP router where you can control everything. So as soon as you have some devices, for example, sitting here, that will detect a new DDoS, can be an IDS, your NetFlow, flow scan-based tool, or something else. What you do, just change some lines in that configuration, and automatically that change will get pushed out to every single device in your network. So it's really easy to do, and you don't mess up your whole network each time you get under a DDoS. And it works quite well. Some big tier 1 ISPs like UNet, WorldCom, and so on are using that technique too. So nothing new, so to say. Another one that you can use, especially if you want to gather information about the DDoS. The first example with route to null zero means that as soon as the traffic hits your edge or your core network, it gets dropped. So you don't have a copy of the packets anymore, unless you have some systems picking up traffic before the core, the edge of the network. But usually it's that fast that you cannot have any device doing that. So what you can do is use the same technique, but instead of dropping all the traffic, you rate limit it. So you will not accept more traffic than, let's say, 5 meg from that source or 1 meg, so you can still get the traffic and analyze it. The approach is basically the same. You have one master. This is the configuration of the master that sends out the information, and in fact, on each slave, we'll use that kind of configuration and say, in the FIB itself, if the traffic is like tagged with a flag saying bad traffic, in that one we're using QoS group 66, just rate limit it to 1 meg and drop everything that is above that limit, so you can still analyze what's coming in. Next topic is worm and DDoS protection. Usually it's quite easy in an ISP network to detect a new worm. You have your usual numbers of HTTP and SNMP flows, and suddenly you have 10 times or 20 times more HTTP flows. That's what's happened like when Code Red, Code Blue, Nimda, and all these recent worms went like live. It's quite easy to see, and if you don't see it, your customer's going to see it and it's going to call you and say what's going on with your network. So Cisco has an answer to that, which is called NBR. It's a network-based application recognition. Like every new feature in Cisco, it needs CEF. It's only the latest, one of the latest iOS release, so it's quite new. Like with TCP intercept, the question is, do we really need something like that? Is it really the router's job to do like IDS and connection killer and so on? One of the side effects when you use that is the TCP handshake, like with the web server sitting behind the router, is already established, and the router will drop the packet as soon as you get the match. So what's going to happen is you're going to have a lot of open connections on the web server, so you'll have to tune the web server stack to be sure that you don't run out of like descriptors. Performance impact, according to Cisco and to people that tested, is 20 to 30%. It's quite huge. This thing also has a lot of restrictions. Like it only supports 24 concurrent URLs, doesn't support, I don't think, Unicode. One interesting feature is that it only checks if you're using HTTP, check the 400 first bytes. So just put a lot of like zeros in front and put cmd.exe or whatsoever after that 400 bytes and you're in. Can deal with fragmented packets, HTTPS traffic, that's normal. It doesn't work with the local HTTP server. You should never use the local HTTP server on a Cisco device to do the management. Use, I don't know, SSH or Telnet or IPsec. Because this is something, every single device that comes with an HTTP server management as a whole, I've never seen one that was not like that. This is some configuration options that you should use to not mess up your router too much in case of load. DDoS, to conclude, what's going on in that field? There's a lot of research going on. A lot of companies are working on new kind of DDoS, what could happen in the next months, years. We have been talking to a lot of people, and usually they just say, sorry, I can tell you because it's really too risky if I give out that information. So let's wait and see. In our opinion, most of the recent worms you have seen were quite gentle. What did they do? Just send some mails to people in your address book. They could have done much, much, much more. Basically, all the worms that we've seen lately, except some that were dedicated to Linux devices like the Lion worm sync, were directed to IIS, Outlook, or to both. So is the next one gonna hit these two Microsoft products again? Who knows? Probably yes. People asked us, what are the effects on the internet stability? Some groups did some research for the latest NANOG meeting in the US, and CodeRed and NIMDA didn't affect the stability of the network. So that was quite interesting. So didn't have side effects on BGP and this kind of routing protocols. What are the trends? The trends are that routers are used as a source. I'm not surprised. So this is an excerpt from just one line excerpt from the latest guide from the CERT about trends in I don't know, worm or DDoS. Something you can download on the CERT website, quite interesting. FX had the link on his slides. When you see that latest, like the GSRs from Cisco are able on the backplane to handle 320 gigabits of bandwidth, if you can just turn that over in a source of DDoS, could be quite interesting. What we are seeing too is that these worms are getting more and more complex and that the agents are becoming intelligent. The agents that you are seeing right now is just get in, infect, and just spread it around. It could be much more targeted to some companies like financial institutes, insurance, to gather internal data and send it out. But we have not seen in the wild these kind of things. They probably exist. And one of the latest things that people like ISPs already know, but it was not so known by the public, is the temporary use of non-allocated blocks. This is a white paper from Doug Song that has been published as part of the research at Airborne Networks, where people use blocks that have not been given out by the ARIN, APNIC, or RIPE NCC to ISPs to do a DDoS and then go out of the net again, or to send spam. And then you try to trace the spam and you see, hey, that source IP address is not even used by any ISP, what's going on? So, because some ISPs don't put protection like on their BGP transit and BGP peers when they do peering, it's kind of easy to do that. And once you did it and you're gone, well, no traces. 2 slides before I give the microphone back to Sebastian. TCP dumping and snooping on routers and switches, this is something people already usually ask us for. What can we do? What can you do? In all the latest iOS releases, like after 12 dot something, you can like TCP dump on the Cisco device. It is CPU affecting. You can kill the device in less than 1 second, so never do it without any ACLs. Do not debug to the console. Always debug to a buffer. Otherwise, if you don't have local access to the router, you can take your car and go there and reboot it. So just keep that one in mind. It's really important. So the first time you do it, you don't pay attention, then, okay, let's go out to the field. You can check the performance impact by doing a shock proc CPU and see what's going on. Don't forget to turn it off when you're done. What you can do too is a tool that has been published in one of the latest FRAC releases, I think 2 or 3 FRAC releases ago, is Tunnelix. What the tool basically does is you take all the traffic, put it into a GAE tunnel to a remote device like system running Linux with Tunnelix. You do the things there like TCP dump, and then you send the traffic back to the router with that tool. This is one of the easy ways on a router. But having that said, you shouldn't do it on a router. because you will, like 95% of the case, you're going to kill it. Or then it's just a customer router that is like less than 2 meg of bandwidth. What can you do on switches? You can do anything on switches with local outputs. So what you can do, you can mirror the ports, which is called a span port. 2 examples of configuration. What you can do is say, I want to mirror that port to that port, and you have to connect the laptop there or another device to gather the traffic. That's what you're doing usually when you put an IDS in your network. What you can do with the latest 1605 from Cisco, 6005, from Cisco is filter the traffic you send to this port, so you don't send the whole traffic and you don't get over the capacity of the local ports. What you can do too in a networking environment, if you use Catalyst end-to-end, you can do a remote span. It's a special kind of VLAN where you say, I want to dump the traffic locally, but I want to watch it remotely. So you just send it over the network to another 1605 where your IDS or gatherer is connected. On the low-end Cisco devices, you just have 1 span port. On the 1605, you have 2, but that's it. What is good is that on most of the switches, the performance impact is really 0 because like the bus or the fabric switch they use has been done to do that. So you can do it quite easily without killing your device, even if you have 1 or 2 gigs of bandwidth running over it. What you can do is, if you want, is check the load with that command ps-c. It's a hidden command that's going to give you the load on the switch. Okay, so back to Sebastian for some administrative things on administration on Cisco devices.
Okay, is it okay? Yeah. Okay, you have several kind of attack you can make against a network. You can attack the physical layer directly with plugging to the equipment or connect on the wire. You can attack the routing protocol. You can also attack the remote management protocols, and you have many of them. So this will be a small overview of which one are in use and what you can do to correctly configure them. So the most standard remote management tool is SNMP, which stands for Simple Network Management Protocol. You have several versions of this protocol which enhance the feature and also the security provided by this protocol. So it's a UDP-based protocol, stateless, which is really easy to spoof. So in version 1 and 2, the only authentication you have is a clear text password in the SNMP request. You can, if you capture some packets, you can read the community, or if the user didn't change the community on his equipment, you just use the public, the standard community, and you get access to the equipment information. So the first things to do is to limit the SNMP traffic to your equipment. You have 2 ways of doing that on a router. The first thing is to do ACL on the interface. So you will block the traffic where's the destination in your router for the protocol for SNMP. So the first line gives you an idea of a configuration. Another way of blocking access to SNMP is to do it at the application level. So in the SNMP configuration, you can specify from which IP address the application will answer to. You can also restrict the part of the SNMP MIB that the user will be able to retrieve. So you can just put a view on it and you say, okay, with this community, the user will only be able to see interface status and nothing else, and so on. In V3, and you can have a user authentication. So you need to provide a username and password in the SNMP. So this should be used. Unfortunately, the tools which are available, either free or the commercial monitoring tool, are usually not implementing V3. So here you have an example how to declare a user with a group. And also you can use encryption for the traffic. So earlier this year, Cisco has a big issue with that because ELMI is a management protocol used for ATM where they embed SNMP request in ATM cell. And by default, ILMI community was activated on all Cisco device with the ATM piece of code inside. It was hidden, so it didn't show up in the configuration. Only some command like show community or show groups was showing this community. And so you were able to access to some information of the router. It was read-write, so you could change the router host name and so on. So this has been fixed now, but yeah. For remote access to your equipment, we strongly encourage to use SSH. So it's available on Cisco devices, depending on the iOS version you are using, but the latest are supporting. Unfortunately, they only implement version 1 of the protocol. This means they were subject of all the vulnerabilities that were found. So we are waiting for version 2 implementation, but it's not on the roadmap. In the latest 12.2, you also have SCP feature, so you can do a copy of configuration of image with SCP instead of the standard TFTP. Yeah, a limitation you have is that you cannot force on the equipment the kind of encryption algorithm that that will be used for the communication. So by they are supporting DES and triple DES if you have a strong encryption image, but the client can force to use DES instead of triple DES. So here you have a sample of the SSH configuration, which is trivial. I won't extend on that. Then you need to, you should create accounts on your equipment, so every single administrator have a different account with his own username password. The previous encryption algorithm that was Cisco proprietary was easy to decrypt, so you have a code, a Perl code for doing that, tools for Palm Pilot and so on. So you should use a MD5 encryption, which is type 7 in the configuration. Type 5, sorry. So you just do enable secret 5, and then you clear text password when you are typing it, and it will be encrypted. Okay, then what you should do is you should restrict the protocols that I use that can be used for remote administration. So in the piece of configuration in the bottom, you can see that you only allow for input SSH as a management protocol. You can also restrict outgoing protocols to avoid someone bouncing from one router to another. If you have a large number of equipment and many administrators, it's more convenient to have a remote database, central database holding all the accounts information and also the authorization information. So you can use Radius or TACAX Plus for remote authentication. And you can also do command accounting. So every single command that is typed on the router will be sent to the accounting server. In the documentation from Cisco, you can see that you can read that it's supported for Radius and TACAX Plus, but only the TACAX Plus is implemented. So even in the configuration, you can activate it for Radius, but it does nothing. Authorization. So on the Cisco iOS device, you have several privilege levels. So the standard level when you just log in on the box is 1. So basically, you only have a read-only access to the configuration, so you can to the information, and you cannot view the configuration. The root level, I will say, is a privilege exec, which is a privilege level 15. which is you can access it typing enable and then your password on the box. You can define per user what kind of command they will be able to type in. So if you have like an operator, you want him to be able to enter on the router and type 2 or 3 commands which need to be high privilege, you can just allow this user to type some commands, and so they don't get access to the whole box. If you are using TACACS Plus for authentication, you can also manage authorization with it. So you can define in your central database all the privilege for each user, and it will be pushed to the box when you are logging to it. Kerberos is also implemented by Cisco. For running Kerberos, you need to have an enterprise version of iOS, which is the biggest one which is available. So you need more memory than a standard router and a bigger flash. So Kerberos is supported for Telnet and SSH. You can map Cisco privilege to a Kerberos instance. So just as, to remember you, Kerberos name is, you have the name /instance at a realm. So you can map the instance into a Cisco privilege. Okay, and unfortunately it's not supported by all the boxes, so the low end and high end doesn't support this protocol. Okay, here you have a sample of the configuration for Kerberos. So basically what you have to do is activate Kerberos on the box. You have to define in which Kerberos realm the box will be. You have to define a key tab. Cisco is calling that SRV tab, which is the private key of the box for authentication and encryption. And you have to define which are your Kerberos distribution center, your key distribution center. Okay, here it is. So here you can define which is the key distribution center, so your central authentication database. Here you have the lines for mapping an instance. For example, engineering will be mapped to privilege 15, and so on. And the configuration is similar on the switch. Okay, now Nico will talk. Will finish the talk with ACL.
Yeah, ACLs and how to do a tripwire-like for routers. And since some of the people asked some slides on MPLS in IPv6. So, it's okay? Okay. So just kind of a quickie on ACLs. You have a lot of more types of ACLs on Cisco devices. You have it in your document. All of them I just restricted it because we are quite time limited. Some basic things. A lot of people think like ACLs on Cisco router just do everything, like they are stateful, they do reassemblies, they do whatsoever. So just to put it clearly, ACLs are not stateful on a Cisco router. They are stateful when you use them like with iOS firewall, but that's it. They don't do any reassembly. So all the attacks playing with packet lengths, more fragment, don't fragment, and so on, are going through. There's a new keyword that is available since some releases. It's log input. So it logs like what packet has been rejected, source IP port, destination IP port, and so on. And it also logs the source interface, that is the interface on the router where the packet has been dropped, and the source MAC address. So it allows you, or enables you to find out if somebody is playing on the local LAN with some spoofing or this kind of things. Until recently, only the first fragment was filtered and going to the ACLs. So you could use some like old attacks against some systems and TCP/IP stacks to with fragmented packets and not being cached by the ACLs. In the latest release, you have a keyword that's called fragment, and I don't want to go into details, but because it's behaving differently if you use levels, like layer 3 or layers 4 ACLs with or without port and so on, and just go to the Cisco website and do the search. The most used type of ACLs are the extended ACLs, where you use IP address, protocols, ports. The established keyword only checks if the hack or RST bit is placed. It's not checking fin, push, or whatsoever, so it's only those two. The other one that is quite new and interesting is the Turbo ACL feature. Up to now, every AC, that is access control entry in ACL, was processed top-down until a match was found. So the bigger your ACL list gets, the longer it takes the box to go through it, so it's really performance affecting. With these Turbo ACL features, in fact, the ACLs are kind of compiled, and they're building a hash table with the references and so on, and you have a constant lookup time that is 5 actions. So as soon as you have not 5 plus, but let's say 20 or 30 ACEs in ACL, it's going to be interesting because you don't affect the processing time, the CPU, each time you had a new ACE. Simple example here on the top, how to do an ACL. And I've seen in some documents, I don't know why, people were recommending to deny specifically TCP and UDP and the full port range, because they were saying that sometimes in the log you don't get the protocol or the port, source port, destination port. I've never seen this, so it's just for information. And another thing is that here on the last line you have the deny. The deny is implicit in the ACL, so it's only interesting if you put like the log or the log input keyword at the end. Where it becomes really interesting is by using ACLs on a multi-layer switch. Like if you have a 16509 with a MSFC card and these kind of things, you can define layer 3 ACLs. That means standard, extended, reflexive, and dynamic. And once you enter them, they are pushed to the NMP or the TCAM. That means that they are processed like wire speed at layer 2. There are some documents that state that the external to Cisco, that even with an ACL of 10,000 entries, you don't see anything on the performance side. So this is interesting, especially when you have people that are using more and more switches with MSFC, that is routing modules in the core of the network instead of routers. Traffic will not hit your routing module unless you use like the log or the log input keyword. You have to deactivate IP unreachables and TCP intercept, so that's the caveats. You can also filter with VLAN ACLs that filter IP level traffic, and it's pushed to the PFC on the switch. That is when you don't use a routing module but just go for some layer 2 device. So you can still use, even if you only have a layer 2 device, a basic switch, IP level like layer 3 or level 4, also ACLs. Router integrity checking. Some weeks ago, I saw on the Tripwire homepage that Tripwire Security is selling Tripwire for Cisco iOS. So I had a quick look at the white paper and asked myself, what are these guys doing and selling? So I didn't find anything new or new concept or new technique in the white paper on how they process. So I just have 2 slides on how to build your Tripwire-like tool for your routers. Can be Cisco, but also Juniper, Unisphere, Foundry, Extreme Networks. Just use the same way. It's quite basic, and you can do that with a simple Unix-based box running some CVS and TFTP server or SSH if you use latest iOS release. So what you should always do is store the routers and switches configuration in central and trusted, of course, repository. For example, most of the providers use CVS. You can get the configuration from the device remotely. You can use scripted telnet. In Perl, you can use expect. If you don't use SCP, you can still go for the old tools like RSH, TFTP, and so on that we really don't recommend. Or what you can do too is have the device send you the configuration. So what you can do is you do an SNMP set you need to have the community, the router IP, and so on, and tell the router, please upload the configuration to the TFTP server you list after the OIDs. So this is quite interesting. I don't think you can do it right now with SCP. I didn't have the time to check. So bad thing is you're probably going to send that clear text over the network. One thing you can do also is on the router side, limit the number of TFTP server the guy can try to use, so that somebody doesn't just poof this kind of request and have the configuration uploaded to his own TFTP server. Next thing is to check. You can check the configuration automatically, like using a cron or add job. When you see, as you export all the changes over syslog, that line configured by username in the configuration, when you see that the router is just booted, or when you get the configuration changed SNMP trap. So as soon as you see that, via cron job, just check the router and the iOS image to make sure that somebody didn't play with. And then the later step, but it's kind of obvious, is you diff the configuration with the one you have in CVS or with your own tool. What are the limitations? One of the biggest limitation, like every time you use integrity checking tool, Tripwire, is do you still trust the iOS that is running on this device or the Catalyst OS that is running on this device? And do you trust the network that is between you or the internal server and these devices? Like I said, the configuration is transmitted clear text or the network. This is something that most of the providers still do. Not a lot of providers use IPsec, no SCP to do that. Keep in mind that you have two files. The startup config file is one that is used when the router boots, and the running config file is the one that is just a copy of the config that is used and in memory right now. You can do exactly the same for iOS and CatOS images, check that the binary images are still okay. We have been trying to find out if Cisco has a local tool on the routers that allows you to do an MD5 sum. I couldn't find one, but it's quite surprising because like Kerberos, the password system and so on use MD5, so it will be so easy to have a command line tool to have the local MD5 like NodePix firewall is doing. If you want to have a look at the MIBs that you have to use to do the SNMP set, it's the Cisco config star MIB, just have a look in there. Another discussion you had some weeks ago is how easy would it be to do a rootkit for a Cisco router? So after some discussion, we found out that it's probably not that difficult as soon as you know MIPS assembly. This is all like public information. The iOS is proprietary thing coded in C, it's closed source OS, it's running on MIPS because the latest Cisco devices are MIPS based. The older ones are Motorola 68 whatsoever. It's the format of the executable, the image you put on the router is ELF, so that's interesting, statically limbed and stripped. So we didn't find any image that is not stripped to get some debugging information from there. A hidden command that you have on the Cisco device is GDB kernel or GDB PID, and put a PID number you can find by doing like show proc. What it does is allows you to run GDB over the serial port. So it's like remote GDB, so you just install your favorite GDB tool and you can try to play with the Cisco device. Also, what you can do when you're in the ROM one, this is basically you end up in the ROM one when you lost the password of the router, you have to boot it, change the config, break it, change the config register and so on. So from there, if you look at the help file, you will see that you have a lot of things like you can do back traces, inject data, so it's quite interesting. The only problem is only a small part of iOS is running, the first part that is used for booting. Interesting information we got from the Inside Cisco iOS software architecture from Cisco Press is that, just reading it, in general the iOS design emphasizes speed at the expense of extra fault protection. Interesting. To minimize overhead, iOS does not employ virtual memory protection between processes. So as soon as you can take over one process, you can attack all the other processes. So just find one that's, for example, listening to the network like BGP, OSPF, SSH server, you can get in and then attack all the rest of the device. And the latest one is like the best. Everything, including the kernel, runs in user mode on the CPU and has full access to system resources. So that means, really, if you are in, you are the god in the house, and you can start to play with iOS and so on. The question, or the open issues we had is when you're running iOS, there is no real tools or commands you can use to play with the kernel memory processes and so on. What you have on the switches is something that's called enable engineer mode that you shouldn't use because you can mess up the whole switch. But there you can do a lot of things, but we didn't find the same function on the routers. Another option would be to, as soon as you can get in and change things, how easy would it be to upload an iOS image of your own and start it without rebooting the box so it don't get noticed? It's up to now not so easy because the kernel is monolithic, so you cannot play too much with it. What they are changing for the latest, what they call Internet Router 10,000, which is a broadband concentrator where you terminate all your PPPoE session when you have DSL at home. You can change the iOS without booting, so that's the first step into that direction. Another problem is that you have a lot of different images that exist. So you have tens of thousands of different images, so it's not easy to produce a rootkit that's, one rootkitted image for every single image that exists. So you would probably have to focus on the service provider releases, and providers tend not to change the iOS release that often. So the latest one is, I think, 12.0.18 or 12.0.19s. And write a nice tool that could patch new images when they come out. This is speculation. We have had some information that Cisco is working on what they call iOS next generation, and that is probably or maybe some plans that they will use, that you will be able to use loadable modules or loadable device. So could be also a good entry point into iOS, but there's no public information about that thing. To conclude, two slides about MPLS and IPv6, because FX told me a lot of people asked him at his latest DEF CON talk. So MPLS, people asked us already yesterday. For me, the M in MPLS stands for marketing. It's just funny because people come to you and say, okay, my boss told me we need MPLS as a network. So the real question is, why do you need MPLS? Do you need MPLS because you don't have enough bandwidth? No, you don't need MPLS for that. Do you need MPLS because you want to do QoS in your network? No. And the best one is, I need MPLS because it provides security. MPLS is just a basic thing that provides, like if you know frame relay, it provides virtual circuits over an IP-based network. It's not encrypted, it's not authenticated. What you can do is surely go for IPsec over MPLS, but that's it. Everything like the VPNs and how they are segmented is done at the routing layer. So you have to trust like BGP and OSPF, ISIS and so on. Otherwise, there's no real segmentation that can happen. What you have on every provider edge router, you have what is called a VRF. It's basically you have one routing table per VPN. If you can attack it, you can play with it. So all these routing protocol attacks really affect the way MPLS is working. MPLS is basically a thing like you had a header in front of the IP datagram or the IP packet to say, okay, this IP packet should be routed that way or that path in the network. Every single router, which is called the label switch router on the MPLS path, this label switch path, has a local table that says if a packet is coming in with that tag, just forward it to that interface. So you can just play with one router and affect one router, or you can also affect all the MPLS passes you have by playing with the routing protocols. So what can you do? How can you attack MPLS? What you should really see is like people always trust the provider when they buy like frame relay from a provider, because they say, okay, the frame relay cloud is on the provider side, it's kind of secure and so on, because you can just talk frame relay with the provider. As soon as you can talk IP with the provider, it gets really more interesting. So what you can do is try to inject packets that have a label that is valid in the network and try to go into a path. On Cisco device, it's blocked by default on the interface, on the customer edge and the provider edge routers. But as soon as you have access to an MPLS router, it becomes quite easy. Another attack is routing protocol-based attack, is just inject data in the signaling protocol that are used to create and maintain the passes in the network. So you have multi-protocol BGP, so it's just like you use BGP to propagate all the pass information into a network, and an IGP. Usually it's OSPF or ISIS, because ISIS allows you to do traffic engineering. And as soon as you can do that, you can change the VPN topology of that customer. So what are the security measures? Well, good configuration on all the routers. You have really to trust the routing protocols you use. You have to trust the iOS you run on the devices. And well, it's really, let's say, security by obscurity, but it's not easy to gather MPLS information from the routers when you don't have access to it. So that's like, it's not security. Last one on IPv6. What is changing with IPv6? All we have seen now is IPv4. Since I left university, back in the university, people already talked about IPv6, and I've still not seen any provider really changing the whole network to IPv6. Basically, there's no new risk or big changes in the way you have to treat the security of your network. The only difference is that you have native IPsec support. For IPv4, IPsec is like an extension, is the second protocol. Like FX said earlier in his talk, and I have to second him there, is that you will have a lot of higher risk when all these providers, enterprises, will move from IPv4 to IPv6. It's new format, not so easy to write ACLs. You will have this IPv4 interconnected islands, IPv6 interconnected islands, so you can really play with it. And then you have also, one thing that is more or less a privacy concern is that your MAC address can be used as part of the IP address. IPv6 is, like I said, no big change. Okay, folks, so that's it. If you want, you can do a small Q&A, and then you can run for food.